All right, so the last thing we didn't cover on this warm-up yesterday was this one, which is the determinant of the 3 by 3. So what's the first step for determinant of 3 by 3? Good. Write the first two columns to the right. And then I want to multiply down the diagonals. I want to go top left, bottom right first. So this would be 2 times 1, or 4. And this would be negative 1 times 4, or negative 4. And this would be 0 times 4 times 2, which is 0. Add them up, I get 0. Then I go back the other way. And I'm going to get 0 times 2 times 4, which is 0. 2 times 1 times 2, which is 4. And then negative 1 times 4 times 1, which is negative 4. And I get 0. So 0 minus 0 means the determinant of this is 0, which can totally be an answer, okay? That doesn't mean it's undefined. If this, the only time that leads to something undefined is if you're doing this trick for a 2 by 2 inverse, and then you put 1 over that. Then the inverse would be undefined. But the determinant itself can definitely be any kind of number. Positive, negative, decimal fraction, doesn't matter. 0, doesn't matter. Everybody was good on homework? Yes? Okay, great. All right, so on your, I put it on the quiz assignment itself, is the quiz review, so you want to get that open. Quiz will cover sections 7.5 to 7.7, okay, which takes you through 7.5 was adding, subtracting, the scalar multiple, and the multiplication of matrices. So remember, like to add and subtract, they have to be the same exact dimensions. So the directions there will say, like perform the indicated operation. If not, explain why not. So if you couldn't add them, you would say they have different dimensions. You can't add a 2 by 3 to a 2 by 2. Has to be exactly the same. Scalar multiple can be done on anything, okay? And then for multiplication, you've got to get the order of each matrix. So like let's say it's a 2 by 3 and a 3 by 1. You check the inner two. These must be the same. And then the outer two are the dimensions of your answer. So the outer two would be the dimensions of your answer. So in this case, like if I had a 2 by 3 and a 3 by 1, then my answer is going to be a 2 by 1. So I'll give you an example there. If I had a 2, negative 1, 3, 4, 0, 5, a 2 by 3, and then a 3 by 1. Okay, it could look like this. So my solution is going to be a 2 by 1, 2 rows, 1 column. So I go the first, remember this by the name, row 1, column 1. This is row 1, column 1, and I multiply that out in pairs. So 2 times 4 plus negative 1 times 2 plus 3 times negative 3. I'd get, this is a 2, 8 minus 2 minus 9, or 6 minus 9, which is negative 3. And then the second one would be row 2, column 1. So I'm done with this one. I'd go row 2, and there's only one column, so column 1. So 4 times 4 plus 0 times 2 plus 5 times negative 3. So this is 16 plus 0 minus 15, which is 1. And then it's negative 3, 1. Questions on adding, subtracting, scalar, or multiplying. So all of that was 7.5. Okay, then came 7.6, which was the inverses. So you're going to get a 2 by 2, and then you're going to get a 3 by 3. So for the 2 by 2, this is where we do the trick, right? We do 1 over the determinant. We switch A and D, and we negate B and C. So if my original matrix was 2, -3, 5, and 4, for example, the first thing I do is the determinant. So it'd be 4 times 2 minus 5 times -3. I'd get 8 minus a -15. That becomes plus, and this is 23. And then I do 1 over 23 times, I switch the 4 and the 2, and I change the signs on the -3 and the +5. And then I distribute that in. So it'd be 4 over 23, 3 over 23, -5 over 23, and 2 over 23. If those were fractions that you could simplify, you need to. Obviously, these are not, so I can leave them. Be careful with your signs on this. And every year, somebody does this the long way. I don't know why. To prove a point, but usually they make a mistake, so I do not recommend that, okay? All right, then the 3 by 3 is the long one, right? So the 3 by 3, let's just say this is my matrix. I'm not going to work all the way through it, but let's just say, because I think we've done something like this, but let's just say this is my matrix. I would rewrite what I want it to be next to it. So the 1, 0, 0, 0, 1, 0, and 0, 0, 1. And then we do our row operations to get the left side to be in that pattern, right? To the 1, 0, 0, 0, 1, 0, 0, 0, 1. And when we get it into that pattern, the right side is my inverse. I will tell you now that for the original quiz, I didn't make a makeup yet, but for the original quiz, these are all whole numbers. Not on the 2 by 2, but on these are all whole numbers, so that, God bless you. So they shouldn't be absolute torture. And if you find yourself with a fraction in the right side, something's wrong, okay? Not maybe in the process, but all the way at the end. So I would work, remember, I try to get a 0 here. A 1 here. If it's there, great. If it's not, you don't have to get that 1 there. If it makes more sense to just go to the zeros, you need a 0. And to do that, you can use either row. You need a 0 where the 7 is. To do that, you can only use the first row if you've already gotten a 0 in the second one. You need a 0 here, and to do that, you can only use the second row. Otherwise, you lose the first 0. You need a 0 where the 6 is, and for that, you can only use the bottom row. Otherwise, you lose the first 0. You need a 0 where the 3 is, and for that, you can only use the third row. Otherwise, you lose the 0 where you use the 0 where the 6 is. There's nothing, no, you don't lose it. There's nothing to change that 0 to get it to cancel. And then the last 0, you have to use row 2. So if you go in that specific order, you are kind of forced into that order. You don't have to do that. You could go in any order, but I would recommend doing the zeros in the rows before you do the ones. Otherwise, you're wasting your time.
For the 3?
Yeah.
Do you have to use the row?
If you've already gotten a 0 here, you're going to have to, because there's no way you could change that 0. But if you wanted to get that one first, you could. Yeah, it doesn't matter. And then remember, whatever ends up being on the right-hand side here after you go through that whole process is your inverse. So you'll rewrite that as your answer. Questions on either inverse process? Okay, and then in 7-7, you had the determinant of the 2 by 2. 2 by 2, which is the easy fish one. 3 by 3, the one that we did on the warm-up where you duplicate the columns. And minors and cofactors.
Hi.
Good morning.
Good morning. I'm sorry to interrupt.
It's okay. Assume we're okay on the determinant of the 2 by 2, right? That's your Jesus fish. Don't forget to subtract, and don't forget to go in the right order. That's the mistakes people make there. The 3 by 3 is what we did on the original matrix. If you're doing the minors, so if it's 1, 2, 3, 4, and you're doing the minors, remember for a 2 by 2, we cross through row and column, and then we'd cross through the other row and column, and then we'd cross through the other row and column, and then the last one, row and column. It switches these. Really, all it does is on a 2 by 2, it switches the corners, okay? Then for the cofactors, you change the ones on the second and the third. So if I'm going from left to right, the 4 would stay, the 3 would become negative, the 2 would become negative, and the 1 would stay. So you change the signs here and here on a 2 by 2. Never the first one, and then never next to each other. Like, they're always diagonal, so if you're trying to figure out the pattern. For the minor of a 3 by 3, and this is where I was telling you yesterday, I think, that like when I did your key, realize that you're not using Notability for your quiz, right? So you can't like draw and then erase your stroke. It's not like that. It's a pencil on a piece of paper. So I did it like really lightly with a pencil. I crossed through, and then I rewrote 5, 6, 8, 9. And then I made myself a grid. I think it's probably the easiest way to do it, okay? And then I did the next, so then you have to erase your pencil. And then you have to go to the next one, cross through. And then I drew myself lightly, right, the determinant. So I just kept going through all of those, and then I went back and did all the determinants, okay? Just be careful, like don't go heavy on your stroke and then have to erase a lot, because obviously a paper can only handle so many writing and erasing. So do it lightly, okay, but do it carefully. And then at the end you would rewrite all of those, figure out all those determinants. You're going to do it 9 times, and then you would rewrite so that's the minor, and then the cofactor, we change the signs on the north, south, east, west, whatever you get in those spots. The actual quiz will say like, minor 1 1, minor 1 2, minor 1 3, like that, minor 2 1, minor 2 2, and then the little spaces for each number. So after you do the work, you're just going to rewrite it into those spaces, and then it repeats it for the cofactors.
So it's like the web assigned.
Yes, I tried to match it so that it was similar.
And how many questions are those?
There's 7. 7, yeah.
For the quiz, are you gonna like say you want questions to solve for all 3, or is it like separate?
It's going to be all, you mean all 9 spots? Is that what you mean?
No, like let's say you get to like a question that involves 7 and 7. Is it gonna ask for what is determinant, what's the minor, and
No. So the 3 by 3 determinant is on there, the 3 by 3 minor and cofactor, and a 2 by 2 minor and cofactor, because that does, because that does, I don't need you to do, the only thing I took out was a 2 by 2 of a determinant, because you do it here. That's all. I just took that one out. And then the long ones, to figure the minor cofactor, that one I think I put together. Those are worth more. The 3 by 3 determinant is worth more, and the inverse is worth more, and then all the rest of them have the equal weight. So I think I did like 10 and 20, so it's like that. Questions? So no calculator tomorrow. Be careful with your multiplication, okay? We're good, yes? Okay.